Hello everyone. So the problem that we're going to be solving today is rotate non-negative elements. This was a part of the weekly contest 486 second problem. This is rated as medium. So let us read this problem. The problem states that you are given an integer array nums and an integer k. Rotate only the non-negative elements of the array and to the left by k positions in a cyclic manner. All negative elements must stay in their original positions and must not move. After the rotation, place the non-negative elements back into the array in the new order, filling only the positions that originally contained non-negative values. Okay, and skipping all the negative positions. Return the resulting array. So, what are they telling me? What are they telling me? The first thing that they're telling me is to keep all the non keep all the negative integers negative keep all the negative elements in place. That means I should do not move them. Do not move them. Okay. Second, keep second what they're telling me is that we have to rotate positive, that is non-negative elements to the left k times. They have said that we need to rotate by k positions. That means we need to do it k times. Okay, and then what they are saying that we need to return the resultant array. Let us see this with an example. Okay, this is not why, this is something funny. Let us see this with an example. First example that they've given me here is that 1 minus 2 3 4. Here 2 and minus 4 should be as is, and 1 should be moved left 3 times, 3 should be moved left 3 times. Okay. Okay, so what it is that we do now? What do we do? So we need to keep them as is. So ideally when we rotate an array, what do? We shift it here. That means one will come here, then one will come here, then one will come here, right? So this happened 3 times. From the first place it went to the last place. This was 1 shift left, then it was 2, then it was 3. So ideally my 1 should have come here, but since they've told me to keep all negative elements in place, do not move them, my 1 goes to the left and directly lands on the place where the next non-negative element was. That is 3. So my first step to the left would be to 3. Then my second step would be back to 1. Then my third step would again be back to 3. Right? Or did I do something wrong? No, this was it. So basically it went here, then it went here, then it again went here, right? And the same thing happened with this. First it went here, then it went here, then it again went here. So the resultant array that I will have to be returning is negative, is 3 minus 2, 1 and 3. This means it was rotated 3 times. Let us see one more example. Here I have two negative integers. These should be as is, and I just have one non-negative. Which I have to rotate 1 time. Since I just have one non-negative integer, that means that there is no other place for this to go. If this was, since this is 1, so this will just come back here once. Even if this was 100, this would have come here twice, thrice, 4 times, 5 times, 6 times. So we can say that whenever we have just one positive, that is one non-negative integer, we just have to return the original array back again. Return OG array. Return OG array. Okay, now let's take the final example here. So here only one non-negative, only one negative integer. Let me just lock it out. This was locked. It cannot move. It cannot move. So what do? I have k as 2. I have k as 2. We have three non-negative elements. So this goes here once, this goes here twice. So what would be my resultant array? My -9 would be locked as is. So my phi went from here to here, that was 1, and from here it went here, that was 2. So my phi came here. Now let's do the same thing with 4. 4 went here, and from here it went here. So my 4 went here, and then the same thing with 6. Here 1, here 2. So my 6 came here, and this is what I will be returning. So from these examples, what observation did we make? What observation did we make? First observation was when number of positive elements, observations. My first observation was if number of non-negative elements equal 1, return OG array. Return original array, right? Because there is no place for it to rotate, right? There is no place for it to go somewhere, so we just have, it just keeps on rotating in itself. So we return the OG array. Second, what did we see? One key observation here was that here, if you see, the number of non-negative elements is 2, and we need to rotate it 3 times, right? So just assume that you have two places, and you have this one element, and you need to rotate it 3 times. So basically you have more rotations than places. So after a point it must repeat itself, right? So if this is to be rotated thrice, it came from here to here, then here to again here, then here to again here, right? So this was 1, this was 2, and this was 3. So it came back here again, right? It has to repeat itself after a point, right? So we can only rotate this. To have a meaningful change, either once or 0 times. So a careful observation here was number of positive elements is 2, and I have to rotate k times. So essentially I will be rotating k mod num times, right? So what is 3 mod 2 is equal to 1, right? So this is the number of times that we have to rotate, because there is no point doing the same work again and again, right? So this, from here it came here, from here it came here, then again it came here, right? There is just no point. This was 1, this was 2, and this was 3. It again came back here, right? This repeated itself after 2 positions, right? After 2 position it repeated itself, right? So hence we just need to do it once. So this is one more key observation, that uh, k is nothing but k mod number of non-negative elements. This was one more observation. Okay, fair. What was my third observation? What was my third observation? My third observation was that I need to keep them as it is, and I need to rotate only on positive, that is non-negative places, rotate only on non-negative places. That was my third key observation, right? So since we are rotating only on non-negative places, we will need what will we need? We will need to keep a track. We will need to keep a track of the indices and the values. We will need to keep a track of indices and values of the non-negative elements, right? Because if you see what we're essentially doing here is that we are rotating 5, 4, 6. Okay, so if this was my values and these were my indices, so this was at index 0, 1 and 3, right? So what we are doing is we are rotating the values, we are rotating the values and we are placing them back in their original indices, right? We are rotating just the values. Listen to it carefully. We are rotating just the values and we are placing them at their original indices. We are rotating just the values and placing them at their original indices, right? Let me just write it down. We are rotating just values. And placing them on original indices. Okay, fair, very fair. So what is my game plan now? How do I solve this? I understood what is it that we are doing. We are reducing the k, then we are rotating and only on positive places, and we are keeping all negative elements as is, and we are keeping a track of the indices and values. Because why are we doing this? Because we are just rotating the values and placing them on the original indices. That is what we are doing. So okay, so, and also most importantly, we need this, right? We need this because if the number of non-negative elements is 1, we are going to return as it is, and also we need the number of non-negative elements to reduce. Okay, so what is my step 1? My step 1 is nothing but to make two arrays which store original indices and values, right? We need that. We need two arrays which store the original indices and values, because that is what we inherently need, right? Then what do I do? Now if you see, length of these arrays would be nothing but number of non-negative elements. This is just blatant truth, that if we are storing the values of the non-negative elements, then the number of non-negative elements is nothing but the length of this array. Okay, so the next step would be reducing my k. Let's just store it as m. So we are reducing my k. Then what we are doing, we are rotating values by k to the left, and my fourth and final step is that we iterate through the indices, and to be very precise, the original indices. We iterate to the original indices and place new values, okay. So ठीक है, this is very easy to implement. This is also very easy to implement. It's just a blatant for loop. This is a for loop wherein you create two lists and just keep on adding any number that is greater than equal to 0. Keep on adding, and along with their indices. In one list you store the value, in other list you store the indice. Okay, fair. This is also simple. It is just one formula. This is also very simple. What do we do? Both of these are of the same length, right? So we just, whatever is original nums at indices of I is equal to value at I, right? So this stored the original index, and this stored the rotated value. Earlier it had the original value, now it has the rotated value, and my I is from 0 to m. What is m? Nothing but this, right? So I hope this is easy. Now how do we rotate? This is the most crucial part, right? Because this and this can be done in O of n. So 1, 2, and 4, if we combine them, it gives me O of 2m plus 1. This is an, okay, let me just write it down here. This is an O of m operation. Sorry, this is an O of n operation. This is an O of m operation. This is an O of 1 operation. Okay, so essentially I can easily say that this is an O of n plus m plus 1 operation, which is nothing but O of n, right? Nothing but O of n. Now 3, how do we rotate? This is where I got TLE. I'm not kidding, I got 2 TLEs just because of this. My logic was entirely correct. I got 2 TLEs just because of this. My logic was entirely correct. I did this, also did this, but I failed here. This is very important. So how do we rotate? The most brute force thing that you can do, is literally rotate, literally shift each element, literally shift each element to the left, to the left k times, k times. So how will this look? This will look for I is equal to 0 to k, because we are doing it k times. I is equal to 0 to k, then we store the first index, right? So what we are doing here, this is my values 1 2 3, and let's say we are rotating it k times, right? So what do? This goes here, right? This always goes here, है ना? So I will first save my first is equal to array at 0. I will save my array at 0. Then what will I do? For j is equal to 0, j is less than m minus 1, and j plus plus, j plus plus, j plus plus. Now why m minus 1? I will show you. So I start here, right? I start here. What it is do? I start at 0. Okay, so now what I will be doing is arr at j is nothing but arr at j plus 1. This is how I rotate. So what will happen here is that I start with 0. So my m here was 3. So I start with 0. So my array at 0 would be array at 1. So here 2 came. It rotated once. Then I have 1. My j became 1. So my array at 1 would be array at 3, because j plus 1. So this came 3. This came 3. And since my j is 1 and m minus 1 is 2, and now my j will become 2. 2 is less than 2 is not true, so it will come outside. So essentially my array now is nothing but 2 and 3, because it rotated. And after this is done, array at m minus 1 is nothing but first. What was my first? My first was 1. I saved it earlier. So this is how my array was rotated once. My array was rotated to the left once. I actually rotated it. I actually shifted each element once. I literally shifted each element once k times. So this will be nothing but k times m. This would be k times m. This is a huge complexity. This is an n squared complexity. If you go to see, this is an n squared complexity. We do not want this. Even though this will solve your problem, this will not give you a correct submission, because this is too slow, very slow. I do not want this. Now you have to think smartly. Right? Rotating, let me write it down. Rotating is a math game, is a game of indices. You don't have to do manual labor. You have to think. All you have to do is think, right? So let's say I had 1, 2 and 3, right? 1, 2 and 3. So let's say this is my rotated array, this is my original array. Okay, now what are we doing? If you see, this on rotation of k is equal to 2 times has to come here, right? because it rotated twice, 1 and 2, right? This has to come here, then this has to come here, and this has to come here. So my answer would be 3 1 2. So how is this happening? How is this happening? So let me write down some indexes. 0 1 2. My k is equal to 2, my m is equal to 3. What was my m? The length of this array, that is the number of positive, number of non-negative numbers. So if you see carefully, if you see very carefully, I need to rotate this by k times. So 0 plus 2, okay, 0 plus 2, I rotated it k times. So I am moving my indice and then I am modding it by m. So it is 2 mod 3 gives me 1, it gives me 1. So this is a very important formula. My rotated index my rotated index is nothing but I plus k mod m. How did this formula come into picture? We are given a length of 3, right? We are given a length of 3 and my k will always be less than this. How do I know that? Because I have made sure my k is this. Because if my k is equal to the number of elements, it is just going to come back same. And if my k is more than the number of elements, then it is going to repeat what is already been done in 1, 2 and basically 1 and 2, right? 3 means it is coming back to the same place. More than 3 means it is repeating the earlier steps, right? So this makes sure that my k is less than m. This makes sure that my k is less than m. So since my k is less than m, to the index I am shifting it twice and then modding it. That means I am shifting it to the left, right? I am pushing it and then shifting it back to the place where it belongs, right? So this is a formula that is to be remembered, and this is how we rotate. And I hope I will quickly code this up, and I hope things will be much more clearer when I code it up. So I have int n is equal to nums.length. Then let's just, now what was my step 2? Make 2 arrays and store original indices. Make two arrays, list of integer, let's say idx is equal to new array list, and we have vals. I made, what is my next step? My next step is nothing but firstly putting stuff inside of this. Obviously I is equal to 0, int I is equal to 0, I is less than n, I plus plus. If nums at I is greater than equal to 0, idx dot add I, we are storing the indices and we are storing the values in order. Nums at I, we are storing the values in order. Okay, now what was our next step? Firstly, we need the number of non-negative elements also. vals.size, or we can also do idx.size, any would work. And what was our next step? Reduce k is equal to k mod m. Then now we need to rotate. Let's just make a rotated array. New int m, because obviously it is the same size as the values array, because we are just rotating, right? So now for int I is equal to 0, I is less than m, I plus plus, rotated at I. So the first index in the rotated array would be nothing but vals dot get. We're now we're rotating I plus k mod m, I plus k mod m. This is all. This is, I rotated my array. So now my rotated array consisted of the rotated array, and now place rotated arrays back for I equal to 0, I less than m, I plus plus nums at indices, sorry, idx at I, sorry, idx dot get I is equal to rotated at I. Right, that's it. Return nums, and I think this should work. Okay, that is it. That is all. I hope. Okay, cannot be divided by 0. Okay, this is something new. Okay, found it. So k is equal to k mod m. This was fine. I just changed the syntax. We missed out on this, right? So what was our second condition is that if there is only one positive, that is one non-negative, then there is no place to shift, right? So this was what was happening. We just return the original array, and now if we submit, okay, now if we submit, things should work. Yeah, there you go. I hope you all understood the video, and if not, please do leave a comment. I will solve your doubts, whatever it is. Thank you so much.